Hey Matrix, welcome to the next video in the Maths Paper 1 playlist. Today we're going over question 9 of the November 2020 past paper. If you don't have the paper, there's a link in the description down below where you can download the paper as well as the memo, and then we can continue with the video. Okay, let's get started with question 9. So question 9 is the optimization question for the paper. So it says, looking at the rectangle box, a closed rectangular box, as the following dimensions and ticks that need to be taken into account. So the first one is the length, the width, and the height are all represented by those variables. Then it says that the length of the base has to be 3 times the width, and the volume is 5 meters cubed. Okay, so then they also give us here the material for the top and the bottom costs 15 Rand per square meter, and for the sides it's 6 Rand per square meter. So taking into account everything that we have, I've drawn the box here. Okay, we know that the length must be 3 times the width. We know as well that the volume equals to length times width times height, and that must equal to 5 meters cubed. Okay, and then they've given us the cost for the top and the bottom, and then the rest of the side. So the total cost over here is going to be 15 Rand times, okay, so 15 Rand and 6 Rand times the top and the bottom, and then 6 Rand times the front, the back, the left, the right. Okay, now let's have a look. 9.1 says, show that the cost to construct the box can be calculated using the following formula over here. Okay, so first of all, we're dealing with a 3D object, okay, and we need to calculate the cost of the material, so we need to take into account the surface area of the box. Okay, now remember, surface area is equal to all the shapes you can see that make up the box. So in the front we have the same shape as at the back, so it's going to be 2 times the width times the height, okay, because that's the area of those two shapes, plus then we have 2 sides that are the same on the left and the right, so that's going to be 2 times W times the length, plus then the top and the bottom will share the same dimensions. It's L times H, so this must be an H, and then the top will share the same dimension, and that's 2 plus W, 2 times L times W. Okay, now we know that L needs to be 3 times W. Okay, so then we can substitute that in, so 2WH plus 2H, then it's 3W plus 2W, 3W. Okay, so by doing that, we obtain the following for the surface area. So surface area is then going to be 6W squared plus 8WH. Okay, so if we sort out all the numbers over here, we should get to 6W squared plus 8WH. Okay, so now that we have the surface area, okay, we can see that this here corresponds to the top and bottom. Okay, and this over here corresponds to the rest, all 4, 1, 2, 3, 4 sides. So 4 sides. Okay, so we can now take this and substitute it into our cost equation. So our cost is then going to be 15 Rand times the top and the bottom. The top and the bottom we said was 6W squared, okay, plus 6 Rand times the 4 sides. Okay, so the 4 sides is then 8WH. Okay, so if we work all that out, we'll get a cost which then gives us 90W squared plus 48WH. Okay, so that's 9.1. Okay, now 9.2 asks you, determine the width of the box such that the cost of build of the box is minimized. Okay, so when we want to minimize something, okay, we're going to introduce calculus into this. So 9.2. Okay, now from calculus we know if we want to minimize a function or find the minimum of the function, we need to find its derivative where it's equal to 0. So I'm going to take the derivative of the derivative of this and set it equal to 0. Okay, so we need to take the derivative of the cost, okay, and set that equal to 0. But we can see that in the cost we have an h, okay? So we need all the variables in the cost formula to be in terms of w. So we need to find h in terms of w, okay? But we also know that they've given us the volume, okay? The volume up here they've given us, and the volume we know is equal to length times width times height. We know that the length is equal to 3 times the width, so therefore the volume is equal to 3w squared times h, and that's all equal to 5 meters cubed. Okay, now we can write this in terms of h, and then we'll have an expression for h over here, which we can then substitute in. So h is going to equal to 5 divided by 3w squared. Okay, now that I have this, I can substitute it into my cost formula and I can take the derivative. So cost is then going to equal to 90w squared, okay, plus 48w. Now we substitute what h's value was, and that's 5 over 3w squared. Okay. Why do I have an extra w here? I shouldn't have that over there. Okay, so therefore we're going to have 90w squared plus, okay, 5 times 8 divided by 3 is going to give you a total of 80. Okay, now remember, here's w to the power of 1, w to the power of 2. So 1 minus 2 is going to give you w to the negative 1. Okay, so keep it as w to the negative 1. It's going to make it easier to take our derivative. Okay, now we can take the derivative. So cost prime of w is then going to give us the derivative of this, which is then going to be 90 times 2 to 180 w plus 80 times negative 1 gives me negative 80, okay, minus 1 gives you w to the negative 2. Okay, but we said in order to minimize it, we need the derivative equal to 0. Okay, so I'm going to set this whole thing equal to 0, which means I have 180w equals to 80w to the negative, oh, sorry, what am I doing? 180w minus 80w to the negative 2. Okay, we can then take that over, okay, which then gives us the following. So we'll have 180w equals to positive 80 over w squared. Okay, can times that across to give us 180w cubed. Okay, is going to equal to 80, which means we divide this by 180 and take the square root. So w is going to equal to the cube root, sorry, of 80 over 180. Okay, if you plug that into your calculator, you should get a value of 0.76 meters. Okay, and that's how we go about doing this question. Okay, if you found today's video helpful, then please leave a thumbs up on the video. It does help a lot. If you have any questions regarding question 9, please leave them in the comment section down below and I'll get back to them as soon as I can. Please go check out the channel. While you're there, please consider subscribing to the channel, and remember, it's never too late to have an OIC moment.